Hi guys, welcome to a new episode of our beginners Roblox scripting tutorials. Today we will be talking about if statements. If statements only allow a specific body of code, aka the body statement, to execute if the condition is met. Now let's go ahead and let's create a script in workspace and zoom in and let's get started. So if statements, they follow a structure. First you say if is a keyword followed by the condition. Then you put in then, the then keyword. If you press enter, an end pops up, and between then and end you will have your body statement. So this is basically the structure of an if statement. Now if we want to put this into practical use, let's say we can create a variable and it will hold a boolean value. So let's name this condition. You can name this anything you want, it doesn't have to be condition. We will go ahead and replace this condition with that. For Lua, you don't need parentheses. So let's go ahead and print hello world. Now if we run this, or if we play it, you can see it prints out hello world. Now what if I wanted to set this to false? If I run it, now what would happen is nothing prints out. That is because this block of code only executes if the condition is true. Now if I wanted to expand this, there are other keywords such as else and else if. So we will be going over else first. So we will say print body1 else print body2. If we run this program, only body2 prints because since we evaluated this first condition and we realized, or the program realizes that it was false, then it will go and proceed, and since we have else, it will print out this statement because no matter what, if this condition is false, it will always print out the else. So that is the else keyword. You also have else if. So else if requires another condition just like if. So let's name this condition 2. Then, and let's go ahead create a variable named condition 2, and let's set this to true. Got that. Let's run it. Now as you can see, it prints out body2 because the program evaluates this to be false, and then it looks on this next condition and checks if condition 2 is true, and it notices that it is true, so then it prints it. Now you can also stack in as much else ifs as you want. So I can go ahead and do this, and let's name another variable named condition 3. Let's go ahead and set this condition 2 to false. And if we run it, what would happen? Body3 should print out. This is because the first block is false, then the second one is false. Then it goes to this third one and it evaluates to true. Thus, this block will execute and body3 will print out. You can also add in an else at the end. Else print nothing is true. And if we set condition 3 to be false, nothing is true. That is because these first 3 blocks evaluate to false, so this else will execute. Ideally, the best way to use if statements is if we want to use math and comparison operators. This basically allows us to take advantage of if statements. So I will go ahead and put a list of math operators. So we have plus, we have minus, multiplication, and division, and these are our math operators. We also have comparison operators such as equals equals, does not equals, less than, greater than, less than or equals to, greater than or equals to. And these are our comparison, and these are our math operators. Okay, now we'll go ahead and do examples using these. So let's say I wanted to evaluate an equation. So if 3 plus 2 is equals to 5, then print correct. So 3 plus 2 should equal 5, which results in this being 5 equals 5, which will execute that print statement, which is correct. Now, if I have 6, this will not print out at all because the if statement evaluates to false. And now it's also worth noting, this is also important, that it's important to distinguish equals equals and equals. This is because equals equals is reserved for comparisons, while equals is reserved for creating variables, declaring them, and instantiating them. Just like how we instantiate a variable, local math1 equals 3. This is how the program or the compiler determines the difference between which equal sign we want. So we can also substitute these numbers in here. Local math3, or you can say total equals 5. So if I put math1, math2 equals total, this should still output correct. And now what if we have an else if and we change up these numbers? Now we could put in our condition, let's say 4 times 4 equals to 16. Now double equals, we can say print statement 2. Let's go ahead, statement 1. And now this else if statement should print to statement 2. And then if we have another one, and now let's go ahead and put our statement in here. So you can say we could use minus. Let's say I want to do 5 minus 1 and let us set it equal to 4. Don't forget your double equal sign, of course. And now we can say print statement 3. Now if you run this, statement 3 prints. Let's go ahead and change this value to an incorrect one. And then let's do division. Else if. Okay. And we can say 6 divided by 3 equals 2. And print statement 4. Statement 4 prints out. These are a list of our math operators that we used. Now let's go ahead and use our conditional operators. So let's go ahead and look at this first one. 3 plus 2 does not equal 6. So if we change this to does not equal, previously we had equals equals, meaning that this body will not run. We changed this to not equals, which is the tilde key. And then we can say print true. So if you run this, it should print out because we did the opposite of what we did before. Instead of checking if it was equals, we checked if it does not equal. So now we have our less than operator. We can say is math1 plus math2, is it less than the total? So in this case, it is evaluated to 5 less than 6. This is true. As you can see, it's true. Because obviously 5 is less than 6. This is also, if you have an equal sign, this means that it is inclusive. So this will still be true. But let's say we had 3 plus 3. This will print out to true because 6 is equal to 6. And the same thing works for greater than, as well as greater than or equal to. So there's this whole concept called short circuit evaluation. This basically means that if the current sub-expression or the current condition that we are on is true, then it will skip the rest of the expressions. For example, we can include the AND keyword and OR keyword to our conditions. So we can have, let's say, actually instead of this, we can say, I will go ahead and create new values. It's local condition 1 equals false. We'll create another one called condition 2. So if you can say condition 1 and condition 2, actually, let's say these are true. Let's go ahead and delete this. So what would happen? Because it is AND, it checks if condition 1 and condition 2 are both true. Thus, it will execute this block statement. So if you run the program, it is true. And if I have an OR, only one of these have to be true. It would also print out true. So let's say I change condition 1 to false. Basically, what will happen is as long as one of these is true, then the statement will print. As you can see, it's true. Now, where does the concept short circuit evaluation come in? Now, as you can see, I have a truth table pulled up. Basically, this V represents OR, and the output is true whenever P or Q, whenever either one of these is true. As you can see, the output for this row, true true equals to true, true false equals to true, false true equals to true. However, the only time where the expression is false is both of them are. Now if we go ahead and look at the AND, we can see that this upside down V represents AND. The only time where the output is true is if both of them are true. That is important because short circuit evaluation plays in for the OR statements. The compiler will basically skip over the rest of the sub expressions if it realizes that the first one or the furthest one to the left is true, then it will skip everything to the right. So if I set this to true, and then I set this to false, as you can see that condition 1 is true, however this one is false, but because of the OR truth table, condition 1 is true, the program does not need to check the rest, and thus it will still print out true. And that's basically short circuit evaluations. Now, cool thing that you can do with if statements is that you can change properties based on a certain criteria. So if I go ahead and create a part in workspace, let me go ahead and reference that part. Local part equals workspace dot part. Now we have reference to it, thus we can access all of these properties. Let's go ahead and change the color. So we can say if, we can create a bool value equals, let's set this to true. So if bool value, then, now notice that for Boolean values, we do not need to use comparison operators such as equals equals or does not equal. Well, this is because the nature of Boolean values either true and false, so we can just straight up say bool value. But on the contrary, you can also, if you really wanted to, you can just say equals equals true. However, that is not needed, so you can just say bool value. Okay, now let's say that I wanted to change the color of the part. So I can say part.brickcolor equals brickcolor.new. Let's change it to eggplant. Let's go ahead and add a task style wait in here just so we can see it change. Change it to 1 second and we will go ahead and run it. As you can see, after 1 second, it changed color because the statement is true. Now if we change it to false, we could change this to false. And let's go ahead and add a print done so that we know if this if statement has executed or not. So we print it out. It only says done because the block is false. So that is kind of the gist of if statements. I hope you guys learned something and thank you guys for watching.